Look, imagine this is your web shop. Users can look at your items, buy them, and manage their credit card information. All of a sudden, you start getting complaints from users. After they visited your web shop, their credit card was used for all kinds of fraudulent purchases. What's going on here? An attacker has found an XSS, a cross-site scripting vulnerability on your webshop, and is now exploiting it to steal your customers' credit card information. But how did the attacker do this? Let's find out. An attacker will go and look at your application. He's on the lookout for something: user input. Any data he can supply that will be used by the server in any way possible. And right here on the products page, we see the get parameter item. It says green apple right now, and a green apple is being shown. So naturally, the attacker will wonder, what will happen if I input something random? Well, that something random gets displayed on the page. Now the attacker may wonder, well, what if I make that something random bold? Well, now the page displays that something random bold. This shows that the input is being parsed as HTML. From here on, the attacker can try to deface the website using, for example, an image saying the user got hacked, but what the attacker really wants to do is execute JavaScript in the context of the victim's browser. A simple example is using script tags with an alert, and we can see that that alert shows the attacker has found an XSS. But the attacker's goal is to exploit this vulnerability, and in our case, steal the victim's credit card information. So let's craft a payload together. The first thing we need is some script tags. Now we need to get access to the payment information of the victim. Luckily, since we're executing code in the context of the victim's browser, the victim is just logged in. So if we make a request to paymentinfo.php, it will return that page containing all the payment info. Now we just get the data from that request. Now we have to use some regex to filter out the name, card number, expiry date, and security code. So now all the data is there. But the attacker still needs to exfiltrate it to himself, since now it just lives in the browser of the victim. But that's not too difficult. The attacker will have set up a server somewhere on the internet and just sends a request to that server with all the credit card data in the URL from the browser of the victim. Time to see that in action. So I'm emulating the attacker and I have a Python web server set up here. We have just crafted this payload, and now the attacker just has to get the victim to click the link with the payload. This can be done through another vulnerability, a phishing attempt, stuff like that. Making a victim click a link is not that hard. So let's visit this link. On the victim's end, we just see some weird data on the screen. But looking at the attacker's web server, we see all the credit card data for this user in the logs without the user knowing it. This is an actual example of how attackers stole credit card details from British Airways in 2018. In 2019, an XSS vulnerability in Fortnite allowed attackers to gain access to sensitive data of over 200 million users. In 2016, an XSS attack was used on eBay to take over seller accounts. These are just a couple of examples that show the impact an XSS vulnerability can have. But that may leave you wondering, how does an XSS vulnerability end up in an application? The root cause is always the use of untrusted data without performing proper validation. What is untrusted data? Well, untrusted data is any data that a user can manipulate. This includes get parameters, post parameters, cookie values, headers, form fields, database information, and much more. Anything that can be influenced in any way by a user should be considered untrusted data, such as the items get parameter in our example from earlier. Identifying untrusted data is one part of the equation. In the next video, we're going to fix the vulnerability in the example we saw today, and we're going to look into how you should adequately handle untrusted data to mitigate XSS vulnerabilities once and for all. See you there!